I'm Eli Wintersheet, and this is Lab 5. This lab focuses on the motion of an AirPod case and a 3D printed structure that are sat next to each other. The motion will be analyzed in both Tracker and GlowScript using the functions in the next slide. The first formula is the gravitational force formula. Fg equals gmm over r squared. The second is the friction force. Static friction equals mu sub s times the normal force. The velocity update formula and the position update formula. If you direct your attention to the lower left-hand side of the screen, you'll see the tracker video that was analyzed to get the data. As you can see, neither objects move close to each other. This is because there is a force opposing the gravitational pull between these two. If you look to the upper left-hand side of the screen, you'll see the Lab 5 code. So right here, we talk about the initial conditions. It starts from rest, the mass of the two objects in kilograms, and we define g, the acceleration due to gravity at the surface of the Earth. The unit vectors j hat and r hat. And then the coefficients of friction that were found on an online database, and then the gravitational constant as well. In the main function loop, the first thing that we do is we determine the distance between the case and the 3D printed object, and then we find the net force by calculating the weight force, the normal force, the gravitational force between the two objects, and then the maximum static friction that could occur. And the way we apply the static friction is by making an if loop, or an if statement, that says if the magnitude of the static friction is greater than the magnitude of gravitational force, then the net force does not take into account any x direction, because there will be no movement, and else the net force will equal the y directional force and the x directional force. This is then repeated for the pyramid as well, and so we update the velocity for both objects, update the time, and append the trail to the object's track. When we run the script, we can see, as expected, nothing moves. The position stays constant at 0, and right here is the gravitational force. That also stays constant because nothing is moving, and so it can't change because the gravitational force is dependent on displacement. So now we ask, what if we waited for a very long time? And the answer to this can be found very simply if we just change the delta t to something like 100 and change the while loop to go until t equals 100,000, and then run it, and we'll see again it doesn't move at all. And this is because the static force, or the static friction, will always be greater than the infinitesimally small gravitational force. You can see it's times 10 to the power of 11 to the power of negative 11, which is too small to have any real effect against friction. The second what if question is, what if there was no friction? And so I rewrote the code and commented out the friction. So if we run this program, we can see that the objects move together. And so we can't see it in here because the object representation is much too large to actually see what the displacement is, because the displacement is times 10 to the negative 10th meters. that's less than a nanometer. And also because of that, the force still doesn't change. But if this were left to sit for a long, long time, eventually you would be able to see these objects move apart. Yes. Thank you.